let's get started. So greetings, everyone. For those of you who are joining us for the first time at Open Repositories 2021, welcome. This is the poster session, virtual poster session. This will run for an hour, and we have 22 excellent presentations. These will be very brief, but the posters would be up. There's a commenting feature enabled. Please use the Q&A option to pose any questions, and after the session you may want to engage with the presenters via the commenting feature on each posters. Before we begin, I just wanted to recognize and thank three of my colleagues. Marie Rauts from Stellenbosch University. She is unable to join us today, but she is my co-chair for this presentation. And we have Jessica Lindum and David Miner. Jessica from Chalmers University of Technology and David Miner from University of California at San Diego. All three have been instrumental in setting up the stage, working behind the scenes to get the posters uploaded and moderate the comments. So huge thanks to them. All the posters are listed in the alphabetical order according to the names here on the page. I'll call each presenter's name and they will run through the presentation. Each presenter has 2 minutes. When they have 15 seconds, you'll hear this bell, and that would be time for them to wrap up their presentation. So without further ado, we will jump right in. The first presenter up is Guljay.
Hello everyone, my name is Gülce. I'm going to talk about our recommender system, which we developed for our repository. Next. We developed a system that recommends articles, theses, projects, whatever in the repository according to the item that the user is currently viewing. You can see the recommendations in the red rectangle. These recommendations are generated by using the features of this item. Next. Our repository uses vSpace 7 and our items are indexed on Solr. Since there are tens of thousands of items in our repository, we had to use Apache Spark to handle big data and partitioning. To implement communication between Spark and Solr, we had to change our Solr configuration standalone to cloud. Next. We use content-based filtering. Our system is based on author, abstract, title, and subject similarities. First of all, we need to extract the features. Next. For feature extraction for abstract similarity, we use different natural language processing methods such as word-to-wake, universal sentence encoders. Next. For title, subject, and author similarities, we use TF-IDF. Next. After extracting the feature vectors, we calculate the cosine similarity. We give different ways to each of the similarities to calculate the overall score. Our system recommends the most similar 5 items to the user. You can see the item viewed by the user. This is about a football game, player and player movements. Next. You can see the recommendations. All of them are about game and game playing, also movements. You can see the scores in the red bullets. Next. We haven't shared our code yet, but we are planning to share it as soon as possible, maybe in a couple of weeks. And you can adapt it to your repository. Thank you for listening. If you have further questions or comments, you can reach us via open@metadata.edu.tr. Thank you.
Thank you. Next up is Blajay Betansky.
Yes, hey, hello.
Yeah.
Yeah, I'm ready. So yeah, if you could please, yeah. So yes, okay, thank you. So this poster presents RCIN, which stands for Digital Resources, a digital repository in scientific institutions maintained by Polish institutes, forming the DRSI consortium, currently developed in project named open resources in DRSI. It is an example of cooperation between thematically diverse scientific institutes across Poland. RCIN is developed to give access to and promote digital resources. The poster covers information on technical solutions applied to increase the accessibility of data. In example, various metadata schema like Dublin Core and Darwin Core, accessibility in terms of user interface, as well as large-scale digitization and underlying infrastructure. RCIN is built as a large-scale repository that holds digital assets from all participating institutions and provides multiple ways to access the data. The repository is available online on rcin.org.pl. Thank you.
Thank you. Renata, you're next. Renata, we are unable to hear you.
Yeah, I don't know.
Okay, maybe we can come back to Renato once he's ready. Let's move on to Abel.
Okay, thank you to be here. My name is Abel del Carpio from Consultec Peru. Next. Next, please. Perupris is the Peruvian project for setting up and operating a national information network on science, technology, and technological innovation, and is led by Consultec. Next, please. Next. Next. The network is designed to be interoperable with PRI systems and open access repositories, and also to allow for direct submission into the National Central Hub Perupris platform for institutions and researchers. Perupris platform is based on open software and open standards, specifically in extension of the already existing network of Peruvian open access repositories with this base. Next. The platform is composed of 5 directories: human talent, scientific production, projects, institutions, and infrastructure. And it aims to provide timely and reliable information on services and the actors, activities, and capabilities in the field of R&D with national coverage. Next, please. Service profile is a set of controlled vocabularies and being developed in order to accommodate for particular information needs on national scope. Also uses standards such as OpenIRED or UPMH, persistent identifiers as ORCID, ROR, DOI, handle. Next, please. The platform is based on DSpace Cruise 7 and provides the core functionality for the platform with Amazon S3, WordPress, a period authentication layer, OpenDistro, and for Elasticsearch for systems monitoring and data analysis, Dremio as a data lake engine for content statistics, Superset as data exploration and visualization. Next, please. The design and development is carried out by for science, and the management, quality, and testing training are carried out by Semicro. Next. An initial partial release will be in the second quarter of 2021. Thank you.
Thank you. Next is Shireen.
And we can try Renato after Shireen because I see him in a list.
Okay.
Okay, my poster, can I start? Okay.
Yeah.
My poster proposes the use of artificial intelligence in the form of Arabic machine translation to develop an Arabic terminology management system in different domains, followed by human post-editing of the MT output. The system shall generate output products such as glossaries and taxonomies. The project management shall include 3 phases: pre-production processes, and post-production processes. The pre-production processes include customizing the engine by setting its parameter to existing Arabic translation memories and glossaries. As for the Arabic generation grammar tool, Arabic language is morphologically and syntactically rich language, and its generation is complex. Thus, the technical design of the Arabic grammar tool is divided into 3 phases. The lexical mapping phase deals with identifying the target lexical items. The syntactic phase deals with the order of words in the node list, and the morphological phase specifies how to form words and deal with agreement, gender, number, and person. The pre-production processes include also developing an adaptive empty feature, beside developing an interactive empty prediction, and also designing a taxonomy generation tool by extracting, sorting, and categorizing concepts based on their semantics. While the production process includes the implementation of the engine, adapting automated matrix to the Arabic language, then full human post-editing of the output, followed by subject to specialist expert review and generating output products. The final phase of the post-production includes the review that shall occur after the project and delivery, and involve the evaluation of the project performance in comparison with the original project specs. The goal is to refine best practice and ensure continuous improvement. Thank you.
Thank you. So let's try Renato again.
You could already unmute your mic, Renato.
Hello.
Hello.
Are you listening?
Yes,
Yeah.
yes, we can hear you.
Sorry for that. So we are from Rio de Janeiro. We are producing a repository called ATRIUM. We are a specialized unit of cardiology in Brazil. We are the biggest one, and the department of the Brazilian Ministry of Health. The next one, please. We are tertiary referral cardiological center. So we make transplants and a lot of very complex events, very complex procedures here. So we have a lot of technological products and intellectual products to manage. And then we have educational department, the biggest one too. So we need to make some ways to deal with this complexity situation. The next one, please. We're dealing nowadays with 2 master degrees courses, some residencies, some medical specialized and multidisciplinary, and the postgraduate courses also. Next one, please. So what the goals? The goals is organize the quality of this data, the memory of the institute, the promote of the popularization of science, social control, and health education. The next one, please. This is our focus. The repository will be the central part of this complex situation. We will deal with this space. We are going to migrate now to the number 7. It's the next generation of this space. We will choose to work with. I suppose that the bell. I need to stop this. That is.
Thanks, Renato.
Oh, sorry. Okay.
Okay, so next would be Sarah.
Yes, hello, everyone. So thanks so much. My name is Sarah Gonzalez. I'm from Northwestern University as a data librarian, but here in my capacity today as community manager with the Invenio RDM project with CERN. So I'll talk more about that. Next, please. So the repository itself is in Venio RDM. If you'd like to visit and learn more, here is the product website. Next, please. But what I want to focus on today is the community. So for over 3 years, this international collaboration has been working on in Venio RDM. It includes many stakeholders from a variety of countries and also different domains. So we've got research, academia, government, industry, all represented. Next, please. So knowing that we have to serve an incredibly diverse population of users who are implementing in Venio RDM, we decided to use DataSet as our main data model because we felt that it gave the best coverage and was also extensible for specialized collections that might need to add more fields. Next, please. So that said, we still had a lot of decisions to make about how to configure certain fields like subjects, creators and contributors. There's many decisions to be made, control vocabularies to incorporate, and we had to agree on how to do that. So in my role as project manager, on which I've served for just about a year, I have taken on duties such as welcoming and onboarding new partners, writing blog posts, but also organizing a group, much like a metadata interest group that we have locally at Northwestern, to get kind of the democratic decision process going to help us decide how to do these customizations to Venio RDM. Next, please. So for our first initial wins, just to go through them really quickly, we decided on the subject control vocabularies to use. Next. We also made a short list of licenses so that we can make that choice a bit easier for a user who's first depositing. Next. And now with those lessons learned, we have a clear path forward on how we will continue. So we're going to talk about some new topics through these various discussion forums you see here. We're making sure everyone's represented and we have a kind of democratic voting process. And then we're going to talk about communities and collections later. So thank you so much.
Yeah, thanks, Sarah. James, you are up next.
Oh, sorry. Here I am.
Yep.
Can you hear me?
Yep.
Okay. My name is James Halliday. I'm going to give a very brief introduction to DataCore, which is the upcoming research data repository for the Indiana University Libraries. You can go ahead to the next slide. DataCore is a new repository for research data. It's been developed in-house, but it's based on the Deep Blue data repository from the University of Michigan. That's where the code base came from. The repository is database or data site compliant, and the underlying technology is a traditional Samvera hierarchy stack. Next slide. Research data files can be literally anything that can be stored in zeros and ones, both very small and very large. This is, of course, problematic. IU has a large tape storage system for use, the Scholarly Data Archive, or SDA as we call it. This provides cheap, easy storage, but tape systems are notoriously slow. We were looking for a way to facilitate moving files around, both for depositors and end users. Next slide. This chart attempts to show the ways we deal with data files. The depositor can put files into a shared directory. We have some automated scripts that move the files around to tape storage and to our Fedora instance. Large files, as in files that may be a terabytes or bigger, those can't be put into our Fedora system due to space limitations, but they can put directly into our tape storage for the end user. So we developed a waiting page to warn the user that there'll be a wait before the download begins, but then we are allowing them to download directly from tape through the live system. Next slide. DataCore is not in production yet, but you can view our still in progress pilot site at the URL on this page. You can ask questions later if you like, or to the poster session itself. And that's it. Thank you.
Thanks, James. Okay. Moving along, next would be Karen.
Hello.
And your slides are up.
Lovely, thank you. Hi, good afternoon, everyone. I'm Karen Jackson. I'm from the Open Research Services team at JISC, and we've presented on our poster an overview of our planned roadmap for Sherpa Romeo over the next 12 to 18 months. I won't go through everything in detail, but to pick out some key highlights, the formation of a Sherpa user group is in the pipeline, which will be open and welcome all users of Sherpa Romeo will be welcome to join this. It'll be an online user group via a group discussion list, and we'll be publicizing that further within the next few weeks. We also have plans for some new data sets to be added to the Sherpa Romeo database, including data on transitional or transformative agreements that have been negotiated by JISC within the UK. And also data sets around open access books and monograph policies. A little bit further ahead into next year, we are working on enhancements to our search functionality and user interface, with plans to bring together all of the Sherpa services into one place and one much easier to use and easier to access service. So if you could show the next slide, please. I won't go through all of this text, but this slide and the next one as well provide some further detail on all of the points that are highlighted on the front page of the poster. So we'd like to invite any users of Sherpa Romeo to visit the poster and have a look at this in more detail, and to please feedback any comments or questions that you have about our proposed roadmap. And if you can go on to the next slide, and then the very final one shows our contact details. And that's it. Thank you very much.
Thank you. Julie?
Yes. Oh, I'm Julie Kelly, one of the two co-coordinators for AFcon Search. The other person is Linda Eels, who I think is with us today too. AFcon Search is a subject repository covering ag and applied economics. And unlike a lot of repositories, we have a number of journals, well over 100. Many narrow in focus, most published by small professional societies, but really a variety of other folks publish them as well. Next slide. They come from all over the world. Next slide. And they come to us with, a variety of different situations that they're interested in. A few people have embargoes. We try to discourage that, but they do anyway. We serve as the preprint server for one journal. We mint DOIs for our journals, in some cases ahead of time, so they can include those in the papers. Most of the journals that we have some other web presence, but they come to us because we can give them a much higher visibility. We go into a big economics index, RepEc. We have a relationship with Google Scholar, and so that's really helpful to them. Next slide, please. We've ended up with these journals because we have a close relationship with a lot of the disciplinary societies in ag and applied economics. We've had their conference papers, many of them for years, and it wasn't too big of a jump to go and say that we wanted to have their journals. Probably our most interesting situation is a journal from an Australian society that's published by Wiley. And economists have an interest in intellectual property. So when they went to renegotiate their contract 1 year, 10 years or so ago, they said, we would like everything that's older than 3 years old to be freely available in AFcon Search. And so we actually get the PDFs from Wiley and upload them. We unfortunately sometimes have the situation of asking that journals be taken out of AFcon Search because they're going to a commercial publisher with a strict contract. We hold off until the very last moment if that happens. And once that paid off, once we struck a different deal and didn't have to actually remove it. Our next slide, please.
Oh, yeah. So Julie, you have a second presentation. You can stay on.
I do. Yes.
Go ahead.
Okay. This one is about how we became global over the years. And we first starting with software, we've been in any number of different software platforms. The first two were homegrown, or the first three, if you count Gopher, we were actually in the text-only Gopher before the web was available to us. We were 10 years in DSpace. Dublin Core isn't a really good match with journal article information. So we went looking for something different. We looked at Islandora, that wasn't quite right either. Now we're with Tind, which is of course Invinio software developed at CERN, formerly known as CDSware. Next slide, please. We started out with 50 papers and all from institutions that were all within 150 miles of the University of Minnesota where we're based. And now we have papers from 50 countries and we have users from 187 countries. Next slide, please. It's those relationships with our professional associations that have really helped us grow. We're a distributed network, which means that in the early days, that meant that everyone did a little bit of work. Every single of the 450 authors at a conference had to upload their own paper. Now we do a lot more with batch. A lot more of the work has sort of fallen to us. We do a great deal of outreach. We go to conferences. We try to convince people not only to put their materials in AGCON search, but also to use it. Next slide, please. We try really hard to listen to our community and what they're interested in. We've taken on many digitization projects in conjunction with our users that want to do that, but don't really have the experience. We've added ORCIDs. We're adding more theses and dissertations. Next slide. We're with TIND, and they're the ones who run the software for us. Even as librarians, we were a little leery about MARC as our metadata scheme, but we love it. And we were very happy with the searching capabilities with the personalization. Next slide, please. And although we've been around for 25 years, it's mostly through the good graces of the University of Minnesota and grants, but now we're looking at endowments, the society is giving us more money, a give button, and some government funding.
Thank you, Julie. Next up is Chloe.
Hi, I'm Chloe McLaren. I'm a metadata librarian at Cornell, and I'm presenting on behalf of our migration team. Next slide, please. As background, for roughly the past decade, Cornell has had at least 3 institutional repositories. So for many reasons, we plan to consolidate several in 2020. Specifically, we were migrating 2 bpress-based repositories into a locally controlled DSpace. Next slide, please. The 2 migrating repositories were associated with different colleges, which meant that they had largely different stakeholder groups. Between them, there were about 32,000 items total. Next slide. Thankfully, because this move was planned pre-pandemic, stakeholders were already on board with it. Throughout the migration, we relied on the content expertise of our stakeholders heavily. Next slide. Due to the pandemic and abrupt work from home orders, we needed to articulate our goals and processes more thoroughly than we otherwise would have. The project team shared innumerable meetings and also an exhaustive time-based planning board so that we could all see what the others were doing. 2 main sources of confusion in this migration were, next slide, please. Content. Files were not uniquely named in the migrating repositories, and sussing out which files were actually the same and which just had the same name was a difficult process, exacerbated by file size and volume and our poor local internet speeds. Next slide. And metadata. bpress does not have a unified system to retrieve all metadata or consistent names for its fields across reports. This confusion was furthered by differences in practice within the same field. Although we scripted crosswalks, many content and metadata files were individually scrutinized during this migration. This project was completed on schedule, and a subsequent stakeholder survey found that most participants were very happy with how the project went. So overall, I'm pleased to report that it was a success. Thank you.
Thank you. Tiago?
Yeah, I'm here. Can you hear me?
Yes.
Okay.
Go ahead.
Okay. Hello, my name is Tiago Ferreira, and I'm one of the authors of the present poster about the ARCA pandemic response. The period that started with the COVID-19 pandemic was by far the most challenging period for us. Besides the obvious and common issues that affected all of us, we saw ourselves having to deal with different aspects of the daily work to keep the IR working. Fiocruz has always been a reference in health-related subjects in Brazil, and the institutional repository ARCA is the main platform to publish and disseminate Fiocruz technical production since its launch in 2011. The IR is composed of 29 communities that corresponds to the scientific technical units of Fiocruz, and the submissions are dealt with 19 open access nucleus that are bound to the same number of libraries. All these entities are spread throughout the country. So you can imagine the challenge that to have everybody working for their homes, each region, state, and city with its own struggles, connectivity, remote access, VPNs, and most importantly, the risk of getting infected by COVID and developing serious symptoms. However, we managed to adapt our way of working, giving a proper priority and treatment to COVID-related subjects. Until today, ARCA hosts over 1,300 scientific works about COVID. As a result, ARCA has had its best indicators during the pandemic period, as shown in the poster, such as number of user sessions, submissions, and number of documents, which is over 40,000 currently. So if you wish to get further details about these challenges, feel free to contact us. Thank you.
Thank you. Taylor?
Hi everyone, so I'm Taylor, I'm the lead developer for the Haplo repository. I just want to run through our poster today about discovery after migration and why it's not as scary as some people might think it needs to be. So next slide, please. So we understand that migrating a repository is a pretty daunting prospect. Like there's hundreds of thousands of records collected over decades that you need to relocate. There's concerns over search engine rankings, just overall discoverability of the research. No one really wants to go down that route of damaging their reputation online, but it doesn't need to be as scary as that. So next slide, please. So moving for discovery extra discovery after moving can be achieved, and those are through some of these factors here. So increasing your search and discoverability with a modern repository, and improved user experience overall, allowing easier access and navigation of the system and increased confidence from your end users. Next slide, please. So you can move your repository in 3 easy steps, or 3 simple steps. So following Google's best rankings, best practices for moving online resources, you need to set up a redirect server, add a CNAME record pointing from your legacy repository to the redirect server, and then while you're migrating the records, create a map of legacy to new access URLs, and then you configure the redirect server to use this. So this ensures that any bookmarks, search engine results, or links in other systems all resolve correctly and doesn't damage your online presence. Next slide, please. Then improving your discoverability by updating repository registry services, registering in Webmaster Console and Google Scholar. We use a lot more metadata tags than commonly used in repository systems, and that allows better indexing. And we only allow HTTPS requests for improved rankings as well. And next slide, please. And these are some of the results that we've achieved. Some of our clients, pre-migration to post-migration downloads up 133.7%, and month-on-month average downloads going up by as much as 285. Thank you all for your time.
Thank you. Kate?
Hi there, my name is Kate Nimatinga, and I'm from the South African National Space Agency. We have an online data repository, which is an online web application repository for research data from an instrumentation network. It's called SANDMS. The data is from about 90 different field instruments spread across Southern Africa, Antarctica, Marion Island, and includes all the metadata for it. And some of our oldest data sets is from 1841. We have about 23 different types of instruments, of which these instruments can have up to 8 different file formats. So I think text, binary, sound files. So we had a lot of metadata we had to create, and we used the diff format. So it's basically an online collection that works like an e-commerce shop. So you'd select the data you want in your shopping basket and check out, and an email will be sent to you with the FTP details. We mainly used open source technologies, including the following: a ZFS file system, Python, Web2Py, and PostgreSQL. The PostgreSQL database, because it offers powerful GIS extensions, which provides hundreds of functions to process geomagnetic data in different formats. So if you would like to have a look at our online repository, please send me an email to dap@sansa.org.za, and I can create a login for you. Thank you very much.
Thank you, Kate. Eric?
I just had to find my unmute button there. All right, so you can go ahead and go to the next slide. We are here at the Center for Open Science, and our mission here is to increase the openness, integrity, and reproducibility of research. Next. And what we're going to talk about today is the infrastructure portion of our mission here at the center. The OSF is a collaborative platform that streamlines the scientific process by simplifying organization and sharing of data and methodologies. And key to this mission is interoperability with additional research tools and multiple interfaces that can accommodate the dynamic research workflows across all research disciplines. Next. So the OSF itself is an ecosystem of services with features and workflows for research planning, conducting, reporting, and discovery. Next. And the OSF is a community-centric product with a roadmap that is defined by a few different convergences, and one of those is this balance between flexibility and specificity of research workflows. And then next is also this constant dynamic and dialogue between the needs and opportunity of these three really big groups. We have members and supporters, our funders that give us grants, as well as institutions and organizations that use some of those services we mentioned before, those that are providing, submitting data, as well as integrators. Next. Oh, yeah, just keep going. So that convergence there is what defines our roadmap. Yeah, go ahead. And so the two ways we enable integrations is one with an open API that allows other systems to exchange data with the OSF, to talk with the OSF. And we have some outstanding partners that already use this. I mean, just click through this one. A couple of examples there, including some that are brand new. And then the other is that we integrate some tools directly into the OSF to make them really easy for researchers to use. And so these include each of those life cycles that we mentioned before, including PID, citation managers, storage and preservation tools that researchers already utilize and value.
Thank you, Eric. Pablo, you're next.
Yep, thank you. Hello, everybody. My name is Paulo Panero, and I work for Synodo. And in our poster, we talked about spam and how to detect it using neural networks. Next slide, please. So let's start from the beginning. What's spam? Spam is content that you do not want to host and show to your users. It's basically not meant to be there. Wait, please, back. Previous slide. Yeah, there's a Monty Python sketch linked below. It's super funny about spam. Next slide now, please. So I'm gonna tell you a story. I was browsing for a movie. I know I shouldn't do that, but bear with me. The Google results were super scary. You have repositories of many types: general purpose, business schools, humanitarian. Next slide, please. Youth, news, lawyers, sports competition. Next slide, please. And many others. And finally, one legit movie streaming. Next slide, please. So I just showed you one Google search, and 9 out of 11 were repositories suffering from spam. So imagine the general case. In Synodo, we discovered 1,000% increase just in 2020. So it's quite scary. And this costs a lot of money in terms of storage, bandwidth, or potential legal actions on copyrights and so on. Social networks and many other platforms are dealing with it. Sadly, repositories are no exception. So next slide, please. If you suffer from spam, have tried to solve it or done something, or are simply interested in it, let's come together and let's solve this in an openly manner. And I'm not going to show the last slide because it's the poster and I want you to go and check it out. Thank you very much.
Thank you. Next up is Ellen.
Hello. For our quick poster presentation, I'm going to talk about Advancing Haiku, which many of you know is a 2.5-year project introducing significant structural improvements to the Samvera Haiku open repository platform. Our partners are the University of Virginia, the British Library, and Ubiquity Press. We are funded by Arcadia, a charitable fund of philanthropists Elizabeth Rousing and Peter Baldwin. Okay, so that's the business part. If this were in person, I would bribe you with candy, but since it's remote, I'm going to try and pique your interest with burning questions you can answer by visiting our poster. So some burning questions. How much can an international open source project team really accomplish during a pandemic? I'll give you a hint. We were all remote before all remote was cool. Second burning question, what do those symbols on our project Gantt chart really mean? Here's a hint. Our creative poster genius Ilkay Holt says they describe the work packages that we are working on in a very creative way. And the third and final burning question, who cares what haiku does anyway? Here's the hint. You do, and you've told us so every time we asked you. We've got surveys, we've got collaborations with the community, and we are ready to share. So I'm going to post this and also our year 2 update that we did recently at the Samvera community. And we hope to see you at our poster. Thank you.
Thank you, Ellen. Next up is Michael. Michael's still there? Okay, we are unable to hear you, Michael. We'll circle back to you in a few minutes.
Here we go. No, I'm good.
Oh, you're here?
Yeah.
Okay, good.
Duh. Sorry. And I will cut this out a bit. I'll just start. The announcement regarding the initial genome sequence of the COVID-19 coronavirus took place on Twitter in January 2020, not in a prestigious paywall journal. What does this say about ideas of prestige, information access, and public health? Next. Many people refer to the 2002 Budapest Open Access Initiative and the others on the slide as a starting point for the OA movement. Next. However, let's look back to almost 4 years before, when the Declaration of San Jose was signed. While the declaration only implicitly refers to OA, it set the stage for major OA projects in Latin America, such as LILAC's Health Information Portal and Cielo, which is expanded to 16 countries and covers all academic fields. Next. Long before COVID, before American European declarations of open access, before PubMed Central launched, before OJS was released, before the rise of institutional repositories in American universities, Latin American public health organizations and governments committed to disseminating free, publicly available scientific publications on the still new public internet. These efforts emerged shortly after a cholera epidemic spread across nearly every Latin American country. In a region with multiple epidemic-capable pathogens and decentralized healthcare providers, open access has been vital to disease control efforts for decades. Next. In other words, this new research culture isn't new at all. The global north simply continues to either write it off as unworkable without saying exactly why, or simply ignores it. We hope that this brief presentation will be the start of a conversation, further research in the context of COVID-19, colonialist ideas of power and prestige. Next. What makes a journal prestigious? What if the genetic code for COVID-19 were published in a journal that costs $30,000 US rather than via an OA platform? Why are libraries choosing complex, quote unquote, OA arrangements that still cost underfinanced libraries millions of dollars, rather than considering a model that already exists? Next. We welcome your thoughts on this topic. Thank you.
Thank you. Okay, moving along, it's Paul.
Okay. Right. Interoperable or integrated? Surely they're the same thing. It's about systems that work together, isn't it? Well, yes, both relate to stuff that works together, but they're not the same thing, not by long chalk.
And the differences matter because the way they function under the bonnet can lead to significantly different outcomes in the real world. There's uncertainty surrounding the terms because different communities active in the repository space have different, overlapping, and even contradictory understanding of the words. And to quote the FAT controller from Thomas the Tank Engine, that leads to confusion and delay. And part of my role involved dispelling confusion and avoiding delay. So I decided to make a poster about interoperability and integration to help and to use in future presentations. So in very unsophisticated terms, interoperable systems are independent systems that can share information through externally facing interfaces. Integrated systems are systems that can share information through internal data exchange. So using the world of hi-fi as a proxy, a separate system is interoperable. Each of the components connects through an external interface and could be exchanged for an alternative that, as long as it complied with an appropriate standard, would function as intended. A music center, on the other hand, is integrated. The connections are made internally. I know this is a gross oversimplification, and I can guarantee if there's someone out there who disagrees, it'll do for now. So how does this affect outcomes? What do you need to consider when deciding whether to go down the interoperable or integrated route, or even a hybrid route? Well, as is always the case, it depends on what you're trying to achieve. Some things you might want to take into account include data fields and types. Do they need to be translated, combined, disambiguated? Do they support widely accepted data standards? Speed of operation. Does the architecture or the infrastructure lead to processing or transmission delays? Upgrades. Will component upgrades have a knock-on effect on other components? And so on. And one last thing, I forgot to add on the poster, it's CC BY, so if you want to use it, feel free. I can supply it in PowerPoint-friendly format if you need. See me after school. Thanks.
Thank you. Vico?
Hi. Hi, my name is Vicko Tomic from University of Split, and I will present the preliminary findings of our research on students' graduate thesis in repositories of European universities. Next slide, please. Our interest in this subject comes from our involvement in the overlay journal ST Open, where we search the repositories of our university to find and adapt students' graduate thesis, provide them public review, and publish them in a journal. So we studied the number and accessibility stages of students' graduate thesis in the repositories of all partners in the CEU Alliance. Next slide, please. This alliance includes University of Cadiz in Spain, Brest in France, Kiel in Germany, Gdansk in Poland, Split in Croatia, and University of Malta. Next slide. The first findings are not encouraging due to the different internal organization and policies of each universities. For example, in Croatia, it's mandatory to publish all theses in repositories, so we have a lot of them in Split, but in Poland is not, so in Gdansk then do not publish them at all. Next slide, please. Also, university differs overall and within themselves in the openness on access to graduate thesis. Next slide. There are differences in the number of enrolled students, published theses, and the level of openness by specific scientific fields. The most theses available in open access were from social sciences, followed by biomedicine and health. Next slide, please. So in these graphs, you can see the openness of access by specific scientific fields, but you can see it later because we don't have so much time. So please skip to the last slide. So the main conclusion is that many students' graduate theses are not published in institutional repositories or accessible in open access, even in the universities with the mandate to publish them there. Thanks.
Thank you.
Thank you.
Maureen?
Hello. I'm Maureen Walsh, Scholarly Sharing Strategist for the Ohio State University Libraries. Making the research and scholarship of Ohio State's faculty, staff, and students openly available allows us to live our land-grant mission, sharing knowledge and culture with the people of Ohio, the nation, and the world. The current scholarly publishing model creates barriers for researchers and has become unsustainable. In alignment with the university's promise of operational excellence in resource stewardship, We are exploring partnerships to transform that model while also ensuring researchers have access to the tools crucial for their work. Under our Transforming the Scholarly Publishing Economy initiative, we have created a plan and a set of priorities to inform and motivate decision-making around directing funds away from paywall subscription models and toward open access publishing. These principles and roadmaps inform our collection strategy, while we also work to apply our equity values of advancing diversity, inclusivity, access, and social justice to scholarly collection building. Our broader goals include educating, informing, and building partnerships with stakeholders across campus to support actions that transform publishing economics, expand avenues of open access to advance Ohio State research, and develop analytics capabilities to inform negotiations and monitor the impacts of new agreements. Our strategic investments in open access follow multiple pathways and include financial support of open source repository and publishing infrastructure, including DSpace, PKP, Fedora, Dryad, DOAJ, DOAB, OAPN, and Archive, a Diamond Open Access Publishing Program, an institutional repository program in its 19th year, participation in Tome toward an open monograph ecosystem, transformative agreements with publishers, and collective action with our consortial partners. Thank you.
Thank you. And we've come to the last presenter, Burjay. I think I may not have said your name right. Sorry for that.
Don't mind. Yeah, thank you very much. Waiting for the slides better. Yeah, welcome to the presentation about the poster Introduce Impact Pathways in a Quiz. I'm Birge Wolf from University of Kassel, and we did this work together with DZ and 4Science. Next slide, please. As you know, societal impact of research is increasingly desired and challenging to access, and we try to deal with that challenges. Next, please. In the Synchronous approach, in order to record the information during the project life cycle at the funder's side, meaning replace parts of proposals and reports, and we focus on activities that increase the likelihood for societal impact. So the next, please, criteria set you see here is the basement of our data model. It has 3 parts: responsible research and innovation, innovation system, and contribution to sustainable development. Next, please. And we add this data model to the DSpace Quiz 7, and we add functions for impact strategies and funding processes that are also part of the data model. It's next, please. The impact pathway that allow to structure items in an intervention logic. We adapt the classical step input, output, outcome, and impact slightly to our needs. Next slide, please. And we allow to have in the step research and interactions a second level to connect objectives on the first level to the activities. And every box you see there is an item of an entity. Next slide, please. We have an additional structure. It's a working plan that allows to structure the items in a Gantt chart and at times and responsibilities and put them into work packages, for example. And yeah, this allows to really work in the environment of the quiz to focus on impact pathways. And yeah, all development will open source. Thank you.
With that, we have come to the end of the session. Thank you all for joining us, and a big thanks to all the panelists. I think with your help, we have run through 22 different presentations in less than an hour. And just as a reminder, the commenting feature is open and available on all the posters. So please, and it would be available till the end of this week, I believe. So please visit all the individual posters and engage with each other. Back to you, Irina.
Thanks a lot, Harish. And I'm showing a slide. What's next? So we will have to go back to SCAD and check a link to the next session, which will be a panel repository rodeo, and then a panel on Iris in a Bloom. And panels and presentation sessions 5 and 6 will continue in the same room, and session 2 24/7 and session 3 24/7 will be on another Zoom link. And we would like to thank our sponsors for science, My Science Walk, Samvera, the Library Code at Maya, and Cayuse. And thanks a lot for joining us today, and see you at next sessions.